show you one feature that is not necessarily new in the latest release of FAMOS, but yeah, it may not have gotten the attention that it deserves until now. So basically what this new feature is, it enables you to write sequences and make them behave like the built-in functions in FAMOS. And because those are sequences that behave like functions, they are called sequence functions. Let me show you how this works. So whenever you create a sequence function, they will appear in the functions library in the libraries category. Now you can also determine different folders. I have my sequence folder here where I have an example sequence function. It looks like this, and if I open up the help section here, you can see I even get some help. So this is some text that I put in there. So I configured this function. Let's see what this does. So we have some function that needs some parameters. It needs to be passed a data set, some filter order, and a cutoff frequency. And the description tells me this function filters a data set with a high-pass filter and then calculates an averaged FFT spectrum of the original as well as the filter data set. Then I have some information on what the FFT parameters are that are used within this function. And finally, the three largest peaks of the filtered FFT spectrum are determined and their corresponding frequencies are output. So basically what this single function does is it is doing a whole evaluation. And to apply this evaluation, again, I can simply use drag and drop. So let's run it on the first channel. I just drag and drop it onto my sequence function, and then I even get the function wizard that I normally only get with the input functions. I get this with the sequence function that helps me to fill out all the parameters. So here I can see I need a filter order. Let's use fourth order again since I used it before, and also the 500 Hz of cutoff frequency. And now I can simply hit run again, and I get a whole bunch of results in the variables list. Okay, let's close that for a second and inspect our results. So again, I have my original data set and the filtered one. This is nothing new. This is what we have done before. So like this, rearrange that. Okay, this is what we already know. But now we also have an amplitude spectrum. So we can show that in a curve window. And maybe let's rezoom that a little bit, like this. And we also have this one for the, oh, I'm sorry, this is already the filtered one. So let's add the amplitude spectrum of the normal data set to this. There we can see how the high pass worked. And then we also have the three largest frequencies of the filtered spectrum. This is also a data set. So here we have the main frequencies. No, sorry, the peak list. So let me add it to that. Of course, I need to change the representation here. So I go right click and open up the lines topic. And I change the representation of this peak list to only symbols, and I want them to show as dots. So right now you can see the three largest peaks inside of this amplitude spectrum. And of course, I also have the main frequencies as a separate data set that I can show inside of the table. Okay, long story short, what I wanted to tell you is I can put a whole evaluation in one of those sequence functions that works the same way as all the built-in functions, and it is very easy to use. So you don't need a lot of knowledge. Now, of course, these functions need to be generated at one point. So there you have two options. Either someone in your company is or feels competent enough and has enough time to build those functions, probably for the whole team. Or for if you, for whatever reason, do not want to put the effort in creating those functions, or probably do not have any time, you can always reach out to us and we can provide this as a service to create those evaluation functions. Yeah, and then of course you can have it, you can always change the code behind it. They are never sealed. You always get full access to them. Yeah, so those are the possibilities.